Right, so today we're getting close to the end of working on circle theorems, but we've got a couple more rules to go. We're going to focus on just one particular theorem today, which is going to be Rule 9. It's about the only theorem that truly has its own name. So this one, all you need to be able to state when you're using this rule is the alternate segment theorem. Okay, so you don't need to know any of the other words in the box or be able to state those, just the title for this one, which makes life a little bit easier. Usually, if you see a question where it says state the theorem, then it's going to be the alternate segment theorem. So you know which one it is. You can write it down straight away and pick up the marks for those ones. So we're going to have a look at this particular theorem in a little bit more detail, and then you can go away and give it some practice. Right, so let's just talk about it to start off with. So it says the angle between a tangent and a chord. So that would be our tangent down here and our chord here, okay, is equal to the angle subtended from the ends of the chord to the alternate segment. Again, a little bit waffly. All we're trying to say, if we look at the first diagram on the left here, is this angle here, A, okay, is between a chord here and a tangent here, opposite it, inside a triangle, because that's the way you want to identify this theorem, is it's going to be a triangle within the circle where all 3 points of the triangle are going to be on the circumference. Okay, and it's not, none of the lines are going to be the diameter, and a tangent on the outside of a circle, that's the one that tells you then it's alternate segment theorem. So this angle A here is exactly the same value as this angle A over here. And then if we go down at the bottom, angle B here, okay, that one is opposite to the angle at the top of the triangle up here, so hence the two B's are equal. And by angles on a straight line and angles in a triangle, this missing angle down here, okay, will make it up to 180 degrees. So A plus B plus this missing side here, or this missing angle here, will make 180 degrees. And A plus B plus this missing angle on a straight line will also make it to 180 degrees. That's why the rule works. Right. I've color coded it here just so that you can see it a little bit easier. So you may want to do that on your knowledge organizer sheet or on your flashcard. So you've got it to look back at and remind you that the two A's go together, which are opposite each other, and the two B's go together to help you figure it out. Right, if you want to give a go at this particular question, have a try, hit pause, and then hit play when you're ready for me to go through it with you. Right then, so to start off with, I've color coded the two angles to get us going. Usually we go alphabetical, so part A wants us to find angle X first, so I've highlighted angle X there with the pale blue, and then the angle that is alternate segment to it is the one down here at 46. So literally for part A, you just need to be able to state that X is in the alternate segment to the 46-degree angle, and hence X is 46 degrees. That's straightforward on that one. Okay, part B, it wants us to find angle Y. So we need to think about where angle Y is and what's useful at that point. And hopefully you can see angle Y is the pink one down the bottom. And by the alternate segment theorem, the pink one up here, okay, at the point C, is its alternate angle. So Y and the one at the top here, the two pink ones then, are going to be equal. So we need to use the information that we've got in the diagram to help us work out that missing pink angle at the top. Hopefully you've spotted we've got an angle on a straight line here. So we can use the angle facts that angles on a straight line add up to 180 degrees to work out the missing pink angle. And then Y is going to be exactly the same as that. So for part B, angle ACB, okay, because it's A to C to B, that's how we can label that one, is in the alternate segment to Y. So using angles on a straight line, we can work out that angle ACB is 180, take away 114, giving us 66 degrees. All right, here's another question for you to give a try, and then hit play when you're ready for me to go through it with you. Right, so the starting point on this one is to try and figure out which angle is going to be in the alternate segment to X, and hopefully you can see that's the one I've coloured red on the new diagram, and hence we just need to be able to use our basic angle facts to work out what the red angle is. So by angles on a straight line, we can do that. So it's going to be 180, take away the 73, take away the 65, which gives us 42 degrees. And then simply by stating by the alternate segment theorem, X is 42 degrees. All right, so you've got a set of questions now to have a go at again. Remember, it could use any of the rules that we've looked at so far, and you must get into the habit of stating the reasons that you're using when you're doing each calculation. So as example, I've done here, angles on a straight line add to 180 degrees. That's why I've done 180, take away 73, take away 65. And then I've stated that I've used the alternate segment theorem to get x is 42. So actually this particular question could be worth up to 3 marks by you doing those calculations and making those statements. All right, there's only one more theorem to do then, so that will be tomorrow's lesson. Remember, if you need any help with anything, use the help sheet and ask at any point.